finding the regular payment when you go buy a car. I got the wrong question. There you go, a car payment. So here are the numbers that I had when in 1997 I bought my first Honda Civic. And I wanted to purchase a $24,000 car that was including everything it had on it. And the dealership offers me financing of 6% per year, compounded monthly, if you pay back the loan in 60 months. Notice that the time is in 60 months, not 60 years. So when you calculate your end, you gotta be careful. Okay, 6% right now, it seems very, very high. At the time, it was kind of like normal. Right now, you can probably get financing for 0%. When I bought my second car, it was when I already was teaching this stuff and I kind of was on top of the numbers and I understood exactly how it worked. And I had already an idea of how much it was going to be and how much interest. It was really useful for me to deal with the car salesman. Car salesmen can be really, really nice, or they can try to bamboozle you into with numbers. So if you go with the clear head as to what the numbers should be like, you have a much better chance of getting a good deal on things. Okay, so what will be our monthly payment? Okay, the first thing we need to do is to figure out what formula to use. So first question is the big chunk of money at the beginning or at the end? Okay, in this case, it's at the beginning. As a matter of fact, everything that time you borrow money, you are getting all the money lent to you up front. And then you're just gonna pay, and be nothing left. So every time you borrow money, it's gonna be present value. Because you get the car and the bank gives you the money, the dealership gets the money, and you pay back the bank little by little. So always present value for borrowing money. And then is it regular payments or no regular payments? Yeah, I'm paying every month, so that's definitely going to be the PV formula. Okay, what is the I? It's 0.06 divided by 12. That happens to work out nicely, so I can use 0.005, or I could just leave it as 0.06 divided by 12. And then the N, I gotta ask the question, what is the number of months in, how many months are there in 60 months? And it's one of those, duh, it's 60. But if you don't ask the question, some people say, oh, if it's monthly, you multiply by 12. And then you get in trouble because you don't have, that's not 60 months, not 60 years, it's 60 months. So the N is gonna be 60. Once you plug it in, here's what you're gonna get. Future value now has a number. And 60 and 0.05, so it's here with 0.06 divided by 12, here with 0.05 to show you both. But I see that I need to figure out this bracket and then bring it down here to the 24. So when I plug this in, hit enter, divided by open bracket 0.005, I get that it's, move over, 51.72556. Make sure that you can get that number and use enough decimal places so we're not off. And that gives us our monthly payment of $463.99. $463.99 paid 60 months will give me the chance to pay back this car 24. But how much interest did I pay? Is it worth it for me to pay extra money to get the car right now? Or should I get a different car? Or should I not get a car at all? Well, to figure out the interest, it's just how much did I pay versus how much did I take. And I know I borrowed $24,000. So anything that I paid above $24,000, it's gotta be interest. How much did I actually pay? Well, I paid $463.99. How many times? 60 times. So multiply by 60, and that's $27,840. So the difference between $27,840 and $24,000 is how much interest I actually paid. Make sense? So in this case, I paid just under $4,000 in interest, which is not really what I paid because I put a lot of money down, so I didn't borrow that much amount of money. But had this been the numbers, I would have paid $3,800, and I'd be like, okay, is it worth it for me to get the car right now for that extra amount of money? Should I get something smaller? Should I get, and then you decide. It's a yes or a no, and that's only a very personal decision. Okay, next we're gonna talk about mortgages, and hopefully it's gonna blow your mind.